All right. So now it's 2 p.m. I want to make sure our audio system is okay. Can you see me? You can hear me, right? The voice is okay.
Yeah, voice okay. We can
All
see
right.
you well.
All right. Thank you, guys. Now today, actually, the topic is since you are here, I believe you have seen the link, you have seen the advertisement. This is a special talk for our library. I got this request last year, so I think every period of time, library organizes this talk for our students. I look at the registration information. Actually, probably 80% above are our PG students, research RPG students. So I think the topic today is rather general. Even though the title seems very specific, but it's very general topic talking about how the student, how we can do the research data management. And my title for the talk is talking about the sourcing and managing the digitized environmental big data from sensor network. So for myself, you can either see from the email link, or myself is Zhi Ning. I'm running a group here in the Division of Environment and Sustainability. In the end, if you see interested topics about this presentation, just feel free to email me. All right, so I'm going to begin my presentation. We have 70 plus participants. That's probably good enough. Okay. Now the first slide is probably to your surprise. Have you seen this one before? This is the B-2 bomber, starting from 1987. It's produced in US. It's a very secret weapon. And just last week, I think, 2 weeks ago, there's an interesting news piece that comes out that caught my attention. So what happened? So the Air Force in the US, they are having to do the reverse engineer for some of the parts from this bomber, this B-2 bomber. The reason is one of these load heat exchangers, they have lost their original design map. All of the technical data have lost on the way. So if they want to produce more of this component is broken, they cannot get it back anymore. And they have to go for reverse engineer, and they send out a tender. The tender is talking about the deliverables have to include all the technical data. So now you see some keywords data related to the heat exchanger, disassembly, and all technical data needs to be blah, 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 blah. So you can see that's actually quite interesting thing that in the history time, even for this top end of the development R&D, it's possible that data can be lost along the way if you don't have a data management. And for this bomber, it's almost like 50 or 40 years ago. So a lot of things were not digitized. I think the data management were not sophisticated at the time. So my title actually is talking about we, as the researchers in the university, we do have the need for our data management, especially in our modern times. You have a flooding of information, what we can do. The second thing is probably, it's also interesting, what this we're talking about, it's even more troublesome. You can see the bomber has lost its design map. That's a big issue already. We have even bigger problem. The whiskey recipe has lost for hundreds of years, and his historian discovered the way to redo the whiskey again. And here, when you look at the data, it's not the technical by numbers. It's talking about the recipe. So the technical data can be lost along the way in the history time if you don't have a good data management program. But at the same time, the data is not simply by numbers. Sometimes it's about the information. So my talk today is to have a few components. I will start to to put you in our shoes, which is our research shoes about the data management. So first of all, you need to understand what we do in our routine research. So that will be probably 5 to 10 minutes. Now afterwards, you have a sense of what we do, and you can think about in this kind of operation, what kind of a research data management may be needed and how we implement. Partially, we cannot even say we are 100% following or do this 100% right. But we do have our the story behind, and what are the key parts for any research data management, and what is our own practice in terms of this process. So lastly, I'll give you only 5 key messages. If you come really late, 1 hour later, you don't miss anything. You have 5 key messages to take home. All right, so that's my agenda. Now, first of all, like I said, I want to spend a few minutes trying to explain what we do. And we do air quality, we do environmental sensors. We are trying to understand our environment, our nature environment and the built environment using a lot of sensors. So that's what we do. And at the same time, if you see from this slide, when we look at the air quality or environmental quality, it always links with other parts. It never stands alone. So when we work with the environmental data, we look at public health information. And we look at how the urban design can change the built environment and how this built environment change can lead to our individuals' health exposure and how air pollution can be distributed differently because of the different urban design. And we also have a lot of information relevant to our transport, the traffic, and energy consumption. So this is transportation, for example, that's a major source. If you had a chance to live in urban areas, not UST here, UST is very quiet. But if you have a chance to live in Kowloon or Central, you are surrounded by high-rise buildings. So the traffic becomes really important. So some of our research is relevant how we can take information from the transportation, how this one can link with our environmental information. So this is the general scheme of what we do. And while the data management seems especially important for our research, if you look at another dimension, say, Hong Kong, you know the area is about 1,000 kilometers square, and we have 18 air stations run by our Hong Kong government. They scattered all around in different districts. At the same time, we have 8 million people in Hong Kong, plus a lot of tourists, and you have 80% of the time inside the rooms. So if you look at the picture right here, this is a picture taken I think the Peio Mountain, and that's actually quite striking. The scheme or the paradigm we are talking about now is you have one station, which is a one data set, is trying to represent the entire city or district. And this is obviously not enough. If you want to achieve our objectives, say you want to have a healthy living, better productivity, even smarter management or smarter governance, we need a lot more information so we can be more specific. This is kind of a precise management that's very necessary for our modern urban, the city management. So this is the work we do. We need to develop many newer technologies, which is a sensor. So the work we do, we have 3 components. Now the first component, you can see the traditional way. One station is trying to represent the entire district. Obviously not enough. At the same time, so we want to have more data, right? We have more data to represent you or represent your home, represent your office, or represent the places you've been to. But unfortunately, this approach couldn't do. So the people have invented or come up some new ideas, say, even in Amazon, you can probably buy consumer sensors, very cheap. But those sensors, if you want to say, I want to use a sensors I buy with $100 to control my entire room, or even to control the factory, should it run by ventilation or by air conditioning or by filtration. Obviously, those sensors cannot meet the target. They are only for implication purpose. So the work we do is professional sensor in between. So once we do this one, the data will be generated in different stages. There are 3 important components in our research here. And we do science, for example, we do engineers, we do applications. In terms of the science, we have to go from the more fundamental level, try to understand the working principles, even develop the prototype for the sensor head, so we can measure more precisely the information with a cheaper price. And we also do a lot of algorithm development. The sensors, they never give you directly the information you want. They always give you the voltage, the light intensity, the current, or even the pulse. Now, these are the very fundamental physical parameters. So how we can link that parameters into the data we want, which is a concentration of the pollutants. There is a process called the algorithm. So we have to do a lot of algorithm development as well. In terms of the engineer, we have to do the system design and integration. And today I have a few examples, which is more relevant to the application side. talking about how we can, once we have this technology in hand, once we have the sensors in hand, how we can make use of the sensors to meet different needs. And once they are put into different places, they start to generate data. And it's actually, this generate a huge amount of the data. So how we can actually manage this big amount of the data, that is something we have to, even internally in our research group, we have been innovating and trying to improve our own process. So what we have done in Hong Kong, in many other places, now this is actually interesting, kind of the summary of, we do, for example, we put the sensors on the drone, we try to capture the emissions from the ships in Hong Kong waters. This one is done in Hong Kong, in many other cities. We also work with the Hong Kong EPD and the Government Flying Service Department, the GFS. So our sensors are placed inside the helicopter. So the helicopter is running across the Hong Kong different regions. So we try to capture the information in the sky about the air quality vertical profile. So that's very important information for us to understand how air pollution is formed and how we can control them. We also have these different sensor networks running at this moment in different bus terminals. You might be familiar with this. If you take a bus to campus or to a home station, maybe you have seen this before. So you can pay attention somewhere in like a Sha Tin or Bayview or Lantin. Those PTI bus terminals, we have our sensors operating at this moment. So you can see we are running different networks, different data generation process as they keep plugging the information in. Not only in this way, you can see what you see is the individual. There are some extreme cases like this one. You can see these are not computer graphics. They are not the modern results. They are real point-by-point measurements. Can you recognize the city here? It's not in Hong Kong for sure. It's way bigger. It's in Shanghai. Shanghai, we have 200 taxi carrying our sensors. They're running in different corners in the city. Every single 5 seconds, they broadcast the data back to the server. And you can imagine 200 taxi, day by day, hour by hour, 5 seconds, one data point. They generate a huge amount of the data. So how we can even store the data, manage the data, and analyze the data, that becomes quite a big issue for our team and for some of our students. They have to stretch ahead in order to find the solutions. So this is a mobile sensor network. And in terms of this kind of a process, it's more relevant to the data transmission. So when we look at the research data management, let's not forget the data is not existing in your hard drive or online. You have to collect them, especially if you do research. There are different ways you can do. There's different communications you have to do. Like the drone case, we do the transmission by 4G in some cases, and we're also developing a LoRa that can transmit by 10 kilometers. So the data, the way we collect the data can be quite different as well. So if you center the data as a keyword in the middle, and around the data, there are many things you can think about. There are many things you need to pay attention to. And this is a very important guy in Hong Kong. He's a top boss in the EPD. So also he came to UST. This is a long area in the UST campus. So we fly the drones. And that's the case I probably mentioned. We have, this is a Mont called the Mega Box. If you ever go to the zero carbon building, in front of the zero carbon building, there are a few lampposts. And the lamppost right here, that's our sensors operating. So we also have this localized, the network, the sensor network that broadcasts the information in real time. The same thing we can also go for the tunnels. Like in these cases, the tunnels has a very long passage, and also it's very special environment. So we also develop this the sensor network inside this tunnels. And another example I probably mentioned just now, this is in different bus terminals in Hong Kong. So all of these examples I give what you can see in the city. We have done all kinds of sensor network. Each time when we form a sensor network, we have to face the problem, how we can manage the data. When the data comes to the server, how we can manipulate, how we can filter, how we can develop the algorithms around the data. So these are the topics we constantly facing in our daily routine research. Not only that, inside the campus, unfortunately, I don't have the link here. Actually, if you type in SCAN, which is a smart campus AI network, I'm going to do an advertisement here. So if you type in scan.ust.hk, scan.ust.hk, you actually come to the website right away. So what's going on here? We have this, we're running 30 plus sensors outside and inside the campus. Inside the campus means in the classrooms, library, LG1, LG7, Starbucks, all these different indoor places, we have the sensors running. And for example, now these sensors, they form a very heterogeneous data sets, because individual sensors, they have a different the data composition. And the approach, the way we put them into different display can also be quite different. So in this case, the sensor network is not the one uniform data format. They are heterogeneous. So we also have to face issues like this to solve. And if you are staff in the UST, or I don't need the student, in the staff APP, there's a one page called Easy Living. So under there, you can also find out the link. You can find it directly where if you go to LG1, for example, either during the noontime, you have to stay away from the the barbecue place. We'll find out that location has a really, really high the PM 2.5 concentration. And I know that smells good, but it may not be good for your health by a reason. All right, so this is a scan in the campus. The data is quite different. The last one, before I move to our real topic, it's just for your side note. Now, in some cases, the data privacy is also important. And the way, now this is the last supper in Milan. We have this small operation in the museum. We try to protect this world heritage. And you know the author, you know the painter of this important painting, Last Supper? It is from Leonardo da Vinci. It's 1495, almost 520 years ago, 30 years ago. So this is a painting in Milan. We are trying to set up the sensor network in there and measure the acidic gases and see how they penetrate into the museum. We have a super, super clean room in this big museum with even gas filtration. But still, there are some gases, the pollutants, they manage to find a way into the museum. So we have to be careful when we do the data collection in order to be really protecting this painting. So everything I was talking about in the earlier 15 minutes or so, they are talking about to describe the shows we are wearing on a daily basis. So you can see what we do. We have different kinds of sensor network. The sensor data can be different format, can be huge amount, can be real time, can be offline sometimes, and they have to come all back in a way, back into our hand. So we have to find a way to manage this data. So back to the original point, what is actually a data management? What is actually data management? The data management, in my view, has two important guidelines. Number one, what is the action? What are the things you need to do in terms of the data management? So those are the actions. The so-called data management is a process of ingesting, storing, organizing, and maintaining the data created and collected by any organization. So this is talking about the process. You have to, there's quite many processes. We have to expand our scope about the data management, simply talking about where to save them, how many copies you save them, or are they saved in a DAT file or Excel file, or database or TXT file. So that's the only part of the data management. So that's about the action. But you have the actions, and it's just like you do the management. You have action, you need to have objectives. What is the purpose? What is the final deliverables? How does it look like? So the data management, in the end, we need to make sure the data in your corporate system, in your groups, in your research group, is accurate, available, and accessible. So these are the basic descriptions of any good data management. There's some other things I don't mention here. That's privacy, what is a subscription protocol, etc. Those are probably beyond what we say today. But at least these are the actions and these are the objectives we need to achieve for our data management. Now, if I expand this one a little bit further, say, what are the key components in the data management? Now, these are probably the few things I expect you to see in your own research work. Let's say, number one, we need to have a data architecture, the structure of your data. It's not simply about how many columns, how many rows of the data you need to have. A data architecture is designed and deployed with a database system and other types of repository. So you need to find a way to have an overview. I will have a few slides to describe this one. So number one, architecture design. Number two, the workflow and the relation. The workflow. The relation is talking about when you have multiple sources of information, how the data can go from 1 tier to 2 tier to 3 tiers. And then we have multiple sources of the data, and they come from different places with different formats. How would you organize the flow and their relationship? And I'm coming to the step number 3. It becomes probably our more limited understanding about data management is talking about the data repository. So where you save the data. Once you generate, process, you have to store them in a database. So what kind of a file system, and do you run by cloud or local hard drive, etc. So this repository is very important component for the data management. The data integration is talking about, for example, the mobile sensor network where I was mentioning. The information we receive is probably more than just the air quality information. It's probably from one of our students also collected the Google, the open source information. It might be images, might be the traffic volume, might be many other things. So when you design your own data management structure in the architecture here, you already have to consider in the beginning, you expect to see what kind of a data structure, and some of the components can be the keys for you to connect with each other. So this data integration is very important. You need to give some thinking before you start your data management. And for sure, there is a data quality check. I don't know about your individual research. In our own research, we have different tiers of the data. So you cannot trust every single number that you collect back. You have to have a filtration process and really the processing process. Okay, the last point about data dissemination. I believe our Debbie can correct me if I'm wrong. I believe in the previous lectures, many of the presenters have talked about how you can share the data, what are the rules and regulations, etc. So I'll probably not talk too much about this one. Okay, so this is my plan for the data management. Now, number one, architecture design. So the architecture design, there's no formula for you to really consider or to follow directly. So, but in any organization or in any research group, when we look at the data flow, there was 3 most important processes you have to take into consideration. And before these 3 and after 3, there are many other things too. But I pick up these 3 because I think these are important. We spend quite some effort thinking about these ones before we do our research. Now, data generation, that's number 1. So the questions we face or you need to answer would be, what is the data sampling strategy? And would you sample our environmental sample, for example? They are from, the process is very simple statistic sampling process. You have the population outside and you take only limited samples. So how would you represent what is the sampling strategy for your data collection from population and best represent the population by limited samples? Are you facing analog data or digital data? And how large is the data set? Are you going to by megabyte or gigabyte or even terabyte? Now this even the database that you need to choose can be quite different. So how large is the data set that you expect to see? And in these cases, we even consider how fast is the data transmission frequency. Sometimes we chase after 1 second, but 1 second there is always limited bandwidth. So how would you compress your data or pick up only effective data for your data transmission? So that all relies on your understanding in this data generation process, how large the data set is. And are you going by real time or time integrated samples? The so-called real time is second by second, minute by minute, nonstop. They come all the time, just like a river flow. The time integrated is every 1 day, you have one sample, you process it, you wait for the next day, you collect another sample. So these are the integrated by time. And similarly, the data by time series of the spatial distribution. The spatial distribution means, are you going by GIS? Are you going by the GIS, the software or the programs to handle the data? If you run by GIS, then the data structure that you need to face and the format of your columns can be very different. So the data entry is also important. Data type and the format and the data filtering needs. Now this one, I cannot give you the formula, but I can raise a few questions to help you think. Once you have a serious research work to do, and you can try to go from the beginning and think about these questions. And from there, when we move on, we talk about our next few slides. You probably have a better sense how you can put you into our shows. The second one I want to mention is about the data communication. I have a few interesting slides. The data communication is talking about how you can pass the information from one person to the other person. Now that's about the data communication. So in a long time ago, many of our data sets were analog. The other one is digital. The so-called analog is continuous. You do the sampling at any single moment, you can get a data point. But the digital is not. Digital is a processed second by second, so it's a discrete. It's not a continuous. So it's a discrete information. So this is where we are looking at the different ages. The data communication can be quite different. Now, this is probably, this is the Great War of China. And in ancient times, this is called a beacon smoke. They fire up the wooden smoke and they pass information. For example, we have a one smoke torch and a one cannon signal. That means the soldiers on top of the watchtowers, they see about 100 soldiers, the enemies. If you have 5 smoke torches, 1, 2, 3, 4, 5, and you have 5 cannon signals, that means you have 10,000. That's going to be a big issue for around the border. So this kind of information this kind of data is communicated in the analog ages. They are communicated by your visual sight. And later on, for example, this is used many in the marine sectors. People use a flex, right, to do the signal. For example, I need help. Or your research needs help, you can flag this one to your supervisor. Okay, you do this. That's how people can see you, and they can get the information from you without talking to each other, without a language. So this is actually another interesting example in the analog ages. Now, in the digital ages, the things can be quite different. So we have invented many different kinds of, like this one is a wired connection by serial port. So you can see the different up and down represented 1 and 0, and this information can be passing from transmitter to the receiver. So the data can be easily communicated. They can be packaged in these waves and easily interpreted by your receiver. And later on, people find out the wireless can do the job too. So the people invented the transmitter, they are not by a wire anymore. They are by the electromagnetic waves. So you have these coupled devices by antenna. So this information, the frequency of vibration, the amplitude of vibration can be easily passed through. So that's how we can realize our data communication. And nowadays there's a 5G and many different new things to try. So data communication is something you can consider in your own research. And for us, sometimes we have very narrow limitations for our selection. Okay, so this is the data communication. Now, number 3 is about the data storage. The data storage is, it has gone through a long time. I think in the prehistory time, during the, I think it's the Homo sapiens time, probably later, people use these knots to represent the characters, like 1, 2, 3, 4, 5. Now, this is in the Asian Chinese, but I believe in other Asian cultures, there are exactly the same thing. So the way you put the knots in a rope that can represent the information to store the data, to store the information. And this is simply by the knot And here you can see that by people, I think this is Edison or before Edison. So there is something called a phonograph that you can record the voice, and the voice is the data. This data can be saved in this phone by the depth of these ditches, and these ditches can also can also be redistributed, and you can pass the voice out. Nowadays we have a CD-ROM or DVD-ROM or even BD, the Blu-ray disc. So this is and inside here you have a laser to beam up the different holes. The length of the hole, the length of this holes represents the up and down the signals. So so here you can do the same thing by storing the information inside the disk. And for the hard drive, exactly the same thing. There are different sectors. The super high speed, a few thousand runs per minute. So you can run through. You can also get information there. And the most striking, best invention in the whole, I shouldn't say in the whole universe, but in our human beings is a DNA. So that's a very smart way of storing the data. So they have this GCA and these different genes that can save tremendous information in a little tiny nanometer scale of the media by DNA. So these are all the things you see these are the three major things you see when you try to do the architecture design, thinking about the medium. And once you have this different data generation process, the transmission process, and also the data storage options, what can we do? Now, I put this one in from our own research, from our own research group. So we have constantly we have a database and we have interface. So this database is like the bin to collect all kinds of information in real time from different networks. So in our workflow and the interrelation between different components, we have this big container that can take these data sets, and we host this one in a cloud. And at the same time, we have another independent IP. So these are two different servers. So this one serves only the database. The other one is another independent IP. So that can save and it can do the interface for us to do the query, to do the data management. So this is basically what we really have. We face in our own research work. So we have many sensors. They come to this database right here. So saved in the database format. And we have this website that can do the web interface. So different people, when they look at a website, many people can do at the same time. They can take the data, view the data, manage the data, or even download the data in real time. So there is no issue of data sharing. They can be very easily passed through. So this is our workflow. It may not be fit for you or your research work, but this is to give you a sense that when you do the data architecture design, some of the things need to be considered in the earlier phase. And in terms of the data repository, I probably have a few slides, just a few main points for you to consider. Say, when you prepare your data, always prepare this one in a way that you expect some other people who are not familiar with the data set. They may not be your classmates, or may not be your lab mate, or may not be your supervisor. It can be somebody who are not familiar with the data set. You have to make sure they can find, evaluate, understand, and reuse the data. So you need to provide the information in a way you don't have to see him or see her, and he can understand or she can understand the information directly. So that actually raises a very important thing for you to answer. Everybody can read an Excel or DAT file or data file, but this data file, they are code numbers, like the code numbers. Numbers has no temperature. So around the numbers, there are many information we need to consider. So you have to consider the difference between different people and how you can make sure that you can pass information to the people. So when you do the data repository or data storage, you have to consider two things. One is always keep in mind the data, they are not numbers. There is a metadata consideration, there is a methods consideration. What are these two? The so-called metadata consideration is, so once you save the data file, you have to save the file along with the information of the project, experiment. For example, the title of the project, who have been involved in the process, what are the key dates, and even for some projects, your supervisors will be very careful that the funders, you have to acknowledge the funders and where the grant comes from. And if you're a PhD student or MPhil student, I strongly recommend you, if your supervisor doesn't require you, I would really recommend you that for the experiments that you do, you should have one report to describe the data and the results. I have one example to show you pretty soon. This is actually a simple example of the metadata. So when you record your experiments, you do the experiments continuously for 24 hours. In the end, what you got may be only a few data points. So these are a few data points, but above the data points, there is many information that can describe the data. So each experiment should come with additional information. And for sure, there's additional information about the data itself. So your 5 data points may represent, it has units, has its own headers, and the way you record them may have to consider how many digits you want to keep. So the information of the data is also inside the metadata consideration, where you have to have the title, the key dates, subjects, versions, and checksums, which is a mechanism to make sure your data set is integrated without corruption. So the description of the headers and the units, how many digits, so we strongly recommend you to consider use a database for your consistent format. So that's as a personal training, as a researcher, as a future researchers. Once you start to use a database, now once you have to face the information about connection between data sets. The data integration process will be much easier in the later stage if you use a database. Because when you store the data in a database, you have to consider early how the relationship can happen among the data sets. The database may not be crazy like MySQL or even the file loop, this big data database. You can simply buy your local, there are many local, for example, SQLite. So these are the simple database program you can use. But the key thing here I want to emphasize is once you save the data, we are talking about the metadata. In terms of the measures, how you can save the data, what kind of measures? Now, it's about the documents, document means record, okay? Document what you did. Document any limitations of what you did. You need a code book, and if you read from the GitHub, the programmers that code the scripters, when they write the scripts, they always have a description in there. That's a very good habit in your data collection process and a data repository process. So if I cannot identify at the side which each bit of the data set means, that you do need a code book or data dictionary to explain your data sets. So the previous 2 items probably can concentrate to one point, which is we have to keep in mind your data set is not just a number. They are not just a number. And they are not just a number for very important reasons. For any organization, it can be a research group, can be a company, can be a big organization or corporation. They operate by the data flow, not only by the numbers. And the numbers is only part of the things and the information. They are mostly the digital data. At the same time, there is a flow of the manpower where we mentioned the projects who have done what. The data is generated during the process with these people ABC involved. So there is a flow of people, flow of manpower. There is also goods flow, the tools that use the equipment that you used for the data collection. And equipment has its own status. Are they in a good condition? Are they out of calibration? So along with that branches, you can see you can link with your another data set where talking about your equipment status. So any organization, the project budget may not be your consideration at the moment. It might be too early, but your supervisor will have a headache on a daily basis about the project budget. So any organization, when they talk about the data flow, not just to say the data is just numbers. I recommend you don't send your email with only an Excel file with nothing to describe the data set. That's not a good habit. Your supervisor wouldn't like it because I don't like it. So keep in mind the data is not just the numbers. And also the data repository, they need to be really, really comprehensive. Now, comprehensive sometimes can be, we really don't have to go by over details. An example of the data storage is in the next page. I want to show here where you can see in our research group, for example, I require our students, once they do this experiment, we need to submit the experimental report. And this experimental report contains what about the equipment, who is doing the experiment, what is the project period, and what is the objective, and what are the design and the test setup. And this one, you have to go by details. I mentioned here the goods flow, right? The goods flow. The reason for these details is if I review the document, if I know this equipment has its own inherent limitations, I can immediately tell my students, say, you have used the wrong equipment for the experiments, you have to redo. If I don't have the information, so when you pass this report to other people, and those people may have a misjudgment or to help you improve your experiment or improve your data collection. So experimental design in our group, we do require our students to describe in details the model number, what kind of instruments, detail the supply information, etc. And also more importantly, the experimental settings need to be included. The reason for this one is oftentimes there is a famous saying the details of the demos, right? You have to be really sensitive to the details. For example, in our research, we deal with a lot of sensors, and the sensors are very sensitive to our environment, temperature, humidity, even the wind, the flow. So if you put your sensors under the air conditioning and you come back and tell me the results are so strange, nobody can help you. But you have to record the information about your experimental settings, then other people can help you. So this is where we mentioned about they're mostly the information before even we see the numbers, before we see the data. When you present the results, our recommendation is, along with the report, all of the raw data, process data, they need to come with a file as an attachment for the report. So they can be in a separate data file with a clear reference of the data name in the report. Say results, I can see you can present a figure. Say this figure, we refer to the data from this file. And this is what we see in the figure. So this is where we say, when you try to do the data storage, they're not just the numbers. Your experimental report is not a simple table or experimental the figure or graph. Try to include more information for the data that includes different flows. Okay, so I finished talking about how we can save the data or how we can pass the information by your data repository. And there are some practical issues we need to consider as well. And people always face the data loss problems. And sometimes it's like sometimes you want to avoid, but it's doomed to occur. Now, how to back up your data, that becomes really important. I have a simple rule for, actually it's not my own, actually, probably other people will have similar things. There is called a 3-to-1. And what is a 3-to-1? So you need to have 3 independent copies of important file packages. Now, really important ones, you don't want to lose them. If you lose them, you cannot graduate, for example. Now, that kind of importance. So you need to have at least 3 independent copies of the file package. The independent means, for example, myself, I have a Google Drive or OneDrive. I synchronize them at least in 5 different locations. And those are not independent. So once you delete one, other places will also be deleted. So the 3 independent copies, they need to be kept separate. So at least 2 different media. So some in the hard drive, for example, in the USB on a hard drive or online at the cloud. So these are the 2 different media. At least 1 offsite. So it's not easily accessible. Or in other words, the offsite means they are not online. They are not something other people can access or delete or accidentally. So 3-to-1 is a very simple rule that we can try when we do the backup. And also use the managed services where possible. For example, UST, we have this OneDrive service, and we also subscribe other like Huawei and Google cloud services, in addition to the local and external hard drive. If you cannot do all of this, then the user ask your seniors in the group and ask the central, our university IT team for advice in this case. So what do you keep in the repository? The experimental report I gave as one example, right? It's a one example of about how you can pass information, how you can save this data plus data information in your computer, how you can pass out as a file package. So that's a way of doing the data storage. At the same time, if you want to keep it for the future record, then you have to consider the one for the long term. So it's not possible to keep everything. Let's face the issue. It's not possible to keep everything. So what can you do if you really have to choose? You have to do some selection. So criteria we can follow by the selection for the data storage would be what has to be kept, like a data underlying publications, environmental recordings, what potentially might be useful for other people, what has a scientific, culture, and historical values, and what legally must be destroyed because of the privacy issues. And this one, I can give one example. We do the vehicle testing, and many of the vehicle testing will work directly with the government. And the government will give us some of the registration information, and we never get the information with a violation of the privacy. So in the end, once we analyze the data, it will be destroyed, or we have to ask for long-sensitive information without individual. So we never know who is the driver, who is registered by which people. We only know the information that's not a privacy violation stuff. Okay, so this is where we can do the selection process. I left a link here in case you are really interested about this subject. You can click on the link later on. All right, now I have two more components to say. The data integration, right? The data integration is talking about when you have different kinds of data sets, you have to face the issues, how you can integrate them together, especially when you face a big amount of the data. So the data integration is where we have to consider all the time. And so we have to keep in mind the data sources, they may come from different types. So the data collected, filtered, and quality controlled and stored in laboratory database. Now that's our starting point. For example, we have this. We run this sensor network in Hong Kong on the buses for a year time. You can see we have in the end we have 70% of the major roadway network coverage, about 100,000 kilometer traveled, 6,000 trips. So 60 million data points in our database, and many different pollutants. So this is the one side of the data. The other side of the data is, at the same time, some of our students, they have developed some new algorithms which can simply look at the pictures from Google Earth, and you can form the sky, from the street view, you can form the paranormal images, and from there you can do some imaging process. You can even identify the dispersion conditions in a city, in different urban roadways. So the deep learning process, you can see we can extract this information. And this information sometimes you see from the advertisement by the autonomous driving. That's exactly the same thing. But here you can see we can also have the data source from other places. So you can imagine when you save the data, they are from the image, what kind of information you can extract from the image and form them into the numbers. And these are only static, right? Static information. The only thing that you can describe it is about the location, the GPS, the coordinates. So how this coordinates when we do the data integration process, even when we save the data in our database, how this GPS location can be linked with our air quality information. So this is actually quite a critical thing to consider. And in the end, what you can do is you can see from here, we can even map the pollutants You can see have a six. When you have the six many images, you extract the information, you connect them with the air quality information. So you can see how you can form this sky view factor in the Hong Kong, which is like how narrow the street is, or how little space you see when you look above. That's the redder you have, that means the more confined, the worse the dispersion condition is. So this is where we say the data integration can have quite different types of the data types. Not only from the Hong Kong, I'm going to bring up the other example from Shanghai. So you can see when you run by a different magnitude. We run Hong Kong by 10 buses. In Shanghai, we run by 100 and 150. And you can see how many data points you expect to see. There are millions of, and each month we're generating 20 million data points. Each month we generate 20 million. And this one has been running for more than a year. You can imagine how many zeros in the data points you have. So this big data set can have a huge amount of the information. So we do have our own considerations about how we can do the data integration. For this kind of a big data, the information that contains can be really, really large. So in the very beginning of the project, or in the early phase of the project, gradually you will see the data integration becomes more and more difficult if you don't consider in the early phase. Every single change of the data sets it means a few days. So the data integration is where we have to consider. I believe in your research, you also have to consider. You may not have the headache like we have with this much data sets, but the different data types, you cannot avoid it anyhow. So if you put the information together in Shanghai, for example, the measurement count versus the roadway segment, so you can see, so this is where the density of the taxi traveling distance. So you can see in the center of the urban in Shanghai, they are very red color. So it's a lot of traveling counts inside the city, but outside the city can be quite different, right? Can be different. So this actually raised my next important question, which is, once we have these many data points, are we keep them all? Are we supposed to keep them all, or any other things we need to do? So if you remember about this one, let me just give before you forget. If you forget the diagram, let me put this one back again. Okay, so here. So what I just mentioned, we talk about the architecture design. We talk about the workflow and the relation, how we can implement a database and a server with a server with the interface platform, and how you can save the data repository, and the data integration. Now, in this part is about the data quality checks. Now, once you find a way to integrate the data, you have a location to save the data. So when you try to do the really the brainstorming or the scholarship development, where you can look into the data for analysis. So this is where we need to pay attention again now, which is data quality check. What kind of a data quality check in a more standard ways we have, and I believe this is more universal. Even though you don't think so in your own data sets, there's something underlying you may have by default, you can simply skip it. But if you expand this data quality check process, we're always talking about three things, at least in our research. Tier 1, we are dealing with the raw data. The raw data definition in our case is very simple. Every single data point from the sensors will be saved in our database, in our data table. So record all of the sensor data with the voltage, environmental conditions, peripheric data, even the temperature inside the machines or the humidity inside the gas pass. So these are all the possible the sensor data we record as a raw from the tier 1. But when you do the analysis, if everything is right, you may not have to consider for the quality control. But in some cases, we have to do the filtration of the data. For example, if our working condition for the sensor collection is we cannot allow the humidity to be above 40%. Otherwise, the instrument is not working in the proper condition. So 40% relative humidity will become our criteria. But this will be inside the raw data. So the second tier we do is we have to do the filtration process. So this is based on a predetermined data validity conditions. For example, there's abnormal out of the range sensor raw data, there is a invalid data, there is a malfunctioning data, there is a data below detection limit. So these are all possible since you can set up the criteria. So from the tier 1 to tier 2, it's relatively automatic. But it's only after tier 2 you can really do your algorithm, you can apply your formulas to do the data. So tier 3 is more on the quality controlled the data. In this process, we also introduce our algorithms. So you have the raw signal to your effective data. So the sensor, for example, only gives you the voltage, but what we need is a concentration of the, for example, CO2 or some other pollutants. So these are the voltage to the pollutants. There's a gap. There are two fundamental physical parameters that you actually measure versus the information that you want to get. So we have to do this one in a tier 3, which is to convert from raw to effective data. And when you do this process, you have another tier of the quality control. The so-called QC, the quality control, it can mean many, many different things. I will not explain in here. The different research areas, different research groups, I believe you have your own practices. Even if you don't have practice, it's also part of the quality control. It's automatic, jumping from raw to the tier 3. That's also fine. That's also fine. But once you have these concepts, I recommend you to think it twice in your own research. Say, do you really have to, or do you need to set up such kind of a tier system to have a QC data? The last point about the whole the key steps is about the data dissemination. I have only one slide. I just quickly read them through. If you plan to share your data in the end, have you got the consent for sharing? And the consent will be from your upper management or from your funder. Do you get a consent for sharing the data? Always email your supervisors if you cannot identify your immediate supervisors. And do any license you have assigned permit your data sharing, permit your data sharing. Is your data in a suitable format? And the permitted format we know is DAT, TXT, Excel, or database, etc. But if you generate some strange data set, or if you zip it, doing the zip it, use a very strange version of your comparison software, and that becomes a problem. So share your data in a suitable format. Are you gone through all the quality checks? So never send long quality control data out, because every time when people have questions, that means your credibility is losing marks. So never send. Always go through the quality checks before you share your data out. And which tier of the data can be shared or should be shared? That's you have to make a judgment as well. And also keep in mind, do you have the metadata attached to the data file that can explain both the metadata and the methods, right? These are two key components. So these are the things I want to remind you when you do the data dissemination. So here we come back to this slide again. So what I have gone through is going from the architecture design for your database, for your data sets, and how you can, when you design your architecture, the structure of your data. Once we say structure, it's not a chaotic, it's organized. That's why we call it a structure, right? It's called a structure. Once you organize, one thing is after the other, it becomes a sequence. It's organized. But once you have organized, it means there must be a flow. It must be a flow. You may not pay attention to this process, but today I try to separate this information to give you a chance to think in the future by yourself. So workflow and relation. And you have to consider how to save your data in your data repository and how would you integrate the data. So this process has to go very early. So when you do the architecture design, you have to think about what is the integration challenge you may face in the future. Last two steps is more on the individual practice. You have to do or design your QC or quality control, quality assurance protocols. in order to make sure your data is quality checked. In the end, when you do the data dissemination, a few things I just mentioned, right? So these are the few things I want to go through by the key components. The last slide, I only have 5 key messages. If I count this one right, okay, 1, 2, 3, 4, 5. 5 key messages for you. Number 1, data is more than just numbers. It comes with a set of properties and a description. Project time, people, model number, etc. Time, the environmental settings. So data is more than just the numbers. Also, data has different tiers from the raw to your shareable or quality check information. Quality control is very critical. Even when you save the file as a tier 1, tier 2, tier 3, always put a label, always set up your own protocol, even write them down or keep them at the record. Say, I do the filtration by limiting by multi-voltage to below 3.3 volts. So for example, so the data always have a different tiers. And number 3, always put the data and the description together in a one repository. It's an echo to the first point. So once you recognize the data is more than numbers, how would you do? I'll give an example just now about the experimental report where you can do easily by saving this information, description, the metadata in one repository, one data package. And also use a consistent format to save the data. The best in the database, if you don't know how to run the database, learn it. It's very straightforward. If you come in the stage for postgraduate study, you should be able to learn by yourself. And this means early planning and systematic thinking. It's a planning process as well. If you expect that data integration is going to happen in the end, you have to plan early. The last one, even though I don't mention this one, but I think it's also important to keep in mind that ethics and intellectual property is very important. So you may ask for your funders, your supervisor, what are the things when you share the data, especially when you publish the data, is any limitations or anything that you need to consider before you share the data for the data management. So we didn't cover this one for today, but these are the 5 key messages. If you come here only 5 minutes ago, I think you didn't miss anything. So these are the 5 key messages I wanted you to take home. So this is my last slide as well. So Gabby, I think we can open the floor for any questions.
Good. Thanks so much, Professor Ning. It's really informative. And I'll open the floor for questions. You can unmute yourself. Feel free to unmute yourself and ask questions. Anyone? Or you can type in the chat box if you cannot speak.
You can also feel free to email me if you have any questions relevant to today.
Well, I have a lot of questions, but
really?
yeah, I always do. While we wait for our attendees to put their questions out, let me just start with one. Now, you have so many sensors, and one thing I find it very interesting in your zone is that very different from social. I'm more familiar with social data. Your data is continuous stream of data coming in. So, in social data, we usually have a clear boundary of this is a set of data, data set 1, data set 2. Now, in your environment, how do you draw the line when you need to handle the data? How do you draw the line? This is set 1, this is set 2, or to you, it doesn't actually matter?
Oh, for sure, it matters a lot. We talk about this one is the tagging of the data sets. Every individual sensor has its unique ID. This ID will be expressed either by the name of the data table or they are inside the data itself. So we always have a way to link between the sensors, the link between the sensors and the data that we see. So that's one connection. The other connection is probably more relevant to your question from the social science angle. So the sensors, for example, some of the sensors are inside the schools. We try to help the children to protect their health or help the teachers to manage their air quality inside the school classrooms. So in those cases, every individual sensor not only the sensor ID, we also need a tag about the sensor location. Say it's under the project A, is in classroom 1 to 3. So those other information will be separate, will be saved during this process. When we do the data integration, those are the label of the sensor data. So that will be stored in another database, data table, inside the same database. So that's how we handle. So we give the labels and the tagging to different sensors.
Right. Now you mentioned earlier, you mentioned your data format can be heterogeneous, right? It's like the data format. So do you save all the data from different sensors and different projects in the same database, or do you have to make different databases for them?
Sorry, Kevin, I didn't hear you. The last question.
I mean,
are the sensors different?
Yeah, their data format is different, right? So do you keep them in one single database to store all your sensor data, data collected from all these different kinds of sensors?
I see that's relevant to the architecture design that we still see from the screen here. That's the architecture design. The every individual the data table that we have, they are independent. They can be
Okay.
30 columns, or some other table can have 100 columns. So that's very common. Very common. It doesn't matter in our case.
Okay. Okay. There's a question from my colleague Jennifer in the chat box. She asked, do you also store data obtained from open sources through integration? So.
Yes, we do. For example, Google Map. But I guess I have to rephrase your question that we do this one not through integration. The integration happens after we do the data collection from different processes. So the image processing is facing it's a different arena. It's quite different again. So from the image to how many parameters you want to extract, you want to digitize the images. So the dimension of the data sets that you can fully describe the images, and it's in your hand. How would you design your model? But when you design your model, it's very important to think about how that data, the data integration, how that data eventually will be linked with our own air quality information. So that's relevant to how you do the architecture design for the open source data.
Thanks, Professor
I
Ning.
don't know if I answered the questions properly, or did I answer your questions at all?
Thank you. Yes.
Okay, I think that's a yes. All right, thank you.
Yeah. So any more question? I have a question about intellectual property thing, but then I want to keep it for later. So please feel free to ask your questions, either unmute or in the chat box, please. Yes, Jennifer, you cannot talk? You are muted. You can speak. You cannot hear you. Okay. So maybe I throw out my intellectual property question. Now, again, it's about ownership. So how do you handle you have a big set of data, very valuable, lots of potential projects. How do you manage who owns what and how other people can use your data to other projects?
It's there are too many scenarios to consider. Again, I don't think there's a formula. There's only a general guidelines. For example, the sensor data. When we look at the sensor data, where they come from, we have a few possible scenarios. If this is a government projects, we don't own the data. We cannot use the data unless the government allows us to. So the government has all the ownership of the data. But they are very much willing to publish the data if this is really useful. So we have a lot of mostly good experience. We never had a bad experience about the data sharing from the government projects. There's another dimension as well. For example, the school, our SCAN, UST HK, the Smart Campus Scale Network project.
Mhm.
So in that sense, the data sharing is very transparent and open. So we push the data in real time to our staff APP. And also there are a few other projects, like the HKUST project and also staff APP. We even have this real-time API we posted on the ITSC, so you can actually go to the link yourself. So this data are very transparent. The data sharing is instant because this is it belongs to our community. So that's a university project. So in that sense, data sharing has no, it doesn't have restrictions or it doesn't have any limitations from our point of view. So there are different scenarios. I think it's more relevant to how the project is funded, designed, and what is endpoint, who is benefiting from the data, etc.
So do you usually enter a project with some sort of signed agreement about like ownership and things like that?
For the research project, it's yes. For the research project, especially when you collaborate with other research teams, some agreements have to be made in the beginning. I think that fortunately we didn't face, at least for myself, we didn't face any issues or argument. I believe there are cases elsewhere. So it's very important to brief in the beginning if it's too late.
Okay, thanks. Now, a question in the chat box about how long do you retain your data?
Oh, it's forever. Unless we are asked to destroy the data. I don't think in my memory, I don't think we intentionally delete the data because they are not used anymore. Now there is only case where we have to face limitation of the size of the database. So we may have some period to do the expansion. Some of the data may be backed up. Some of the data we may consult with the users because sometimes we don't store data only for our own research. We help other research collaborators or clients to do the data processing. So they have to find a way to save the data, but we never intentionally delete them.
But then do you save the data, keep the data in this raw form, or do you keep the quality checked part or the filtered part?
Actually, three tiers. All of the three tiers data all in the database. We have an interesting project. It's called a Praise project.
Yeah,
it's
I saw that,
also
yeah.
from our UST professors. So in that project, we have implemented a more rigorous tier 1 to 3 process, and those data has been stored even now from our own database. So it's a tier 1 to 3. They're all there.
So you keep them all?
Yeah, we keep them all.
Okay, interesting. Good to know.
Data storage is very cheap these days.
Right.
Sometimes it's not a good thing because you are buried in the ocean of data, and sometimes we say the wrong data even worse than bad data. Or even worse than without data. So when you have to dig out information, and when your database is growing from megabyte to gigabyte to terabyte, each time when you try to dig something out, the cost of time and manpower will also grow. So the architecture design becomes really important in that case.
Yeah, that comes back to your point that plan ahead, right? Research data management. Even when you can technically keep the big amount of data for as long as you want. So do you have how do you make sure 20 years later people can still read your raw data in your current architecture?
I don't know how important our research can be now, but the one thing I think is important that for example, when we do the projects, especially with the government projects, every time in the end, and also during the project, every month, we have a big data file, and we also send along with the one experiment, one project report monthly. So that monthly report will contain all the meta information along with the data. So that's a kind of a project basis operation.
Right.
But in terms of the experimental basis, it's more small task based. As I showed in the slides, even internally, we try to keep the experimental report as a format. So you said that after 20 years, I believe after 20 years, as long as the data is been safely saved there, and if some other people identify, they can still read the data file, they can still read the experimental report, they can still recover what has happened 20 years ago.
Cool. Okay, interesting. Yes.
Abby?
Yeah, Diana, yes.
Yes, I have a question for Professor Ning as well. Professor Ning, this is Diana Chan also from the library. You know that you just talk about the data repository, and then you use different kind of, you have that 3-2-1 criteria. So I don't know whether or not you know that the library has our own data repository, which make available to the students, to the PG students as well as the faculty to store their data. Probably what you are having right now, you do not use the library's data repository. So I wonder whether or not you would also recommend your students to have the data resided and stored in our repository.
Yes, actually, Diana, I was just told by my student, one of my team members, the library has exactly this, not exactly, has a data repository to allow us to save the data. I just knew about this one last week. I didn't know about this one before.
Okay.
But for sure, I will be interested to see how it's designed, and if this is useful for us. For sure, we believe it's very safe. I think it's free. So for sure we will explore ourselves in the future. But I just got to know.
Okay.
You have to do more advertisement in the future too.
Gabby, we need to work
Yeah,
on.
thanks. Yeah, thanks, Diana, for jumping in to point out that. I think what a quick answer to this is that I guess in Professor Ning's case, what I saw from your presentation is that our repository would be very good for your say when you said you have these project reports, right? So you have a data set that is attached to this report, or a data set that is attached to a journal articles, or a data set that is attached to a conference presentation. So that kind of what we call the underlying data set, not your whole raw data like in your repository, but a certain small subset processed, filtered, quality controlled, and analyzed data. That kind of publication or report related data set, that would be very appropriate, or very, our repository, data repository would be perfect for that purpose. But we are not in the situation to support your general data, like all your raw data kind of storage. It's not that kind of repository. There are different kinds of repositories. Yeah. So
that's a different scenario, I believe. Yeah, I agree.
Yeah. So in the scenario of your student reports, even if it's not journal publications, encourage them to contact us. We can help them put them up, and they would have a DOI also, and then they can use it for to disseminate, to share, or to send to publications.
Yes.
Yeah. Okay, thanks, Anna, for that question.
Excuse me, I have one question.
Yes, please.
Yeah, so let's say if you obtain open source data set, let's say from like EPD, and would you do their own data validation or some kind of QA/QC after you obtain the data set, or would there be crucial things after you obtain an open source data set regarding the experience in data analysis in Professor Ning?
It depends on what kind of the data conversion process you are going to do. For example, when we look at the images you download from the Google Map, the images that you process, that's what you have in the beginning. When people publish the open source, they come up with a guideline of the data usage, in which the a serious organization will also describe the data and identify what are the potential faults in the data sets to catch your attention. And if this one doesn't exist, it's probably your own, for your own benefits and interest. You have to use this cautious and try to identify the bugs in the data processing. And so I think it's a learning process. It's not about the regulation or the rule or the guideline. It's a learning process during the data conversion process.
Okay, thank you.
Okay, Gabby. Now I have to leave in within 5 minutes time. I have to run for another. We can probably see last 1 or 2 questions.
Yes. Is there any one last question? Feel free. If not, then I guess we better let Professor Ning go, so you don't have to really rush. And thank you very much. It's really very systematically planned out, very informative, very interesting. It's a very good complementary talk compared with our previous talks that are more on social data, and it's very interesting. So, and I really like your B2 example and the whiskey example. That's great. I may use it in other talks too. So thanks a lot, and yeah, thanks so much. Yeah, thank you. Bye bye.
Bye bye.
Hi, Christina。
sorry 啊，Gary，你約咗阿 Wendy 開會係嘛？
係啊，你哋邊度開啊
？I see learning space。
好啊，我應該過嚟，我而家close up 個 talk，我再過嚟啊，好唔該你，拜。